on-chip data memory organization is shown in this figure. The 128 byte internal RAM is organized into three distinct areas as shown in the figure. The three parts are, very first is, there are 4 banks of 8 registers each. The total 32 registers have the addresses in the range 00H to 1FH. The 4 register banks are numbered 0 to 3. That is, they are named as register bank 0, bank 1, bank 2 and bank 3. You can see the addresses are ranging from 00H to 1FH. The registers inside the bank are named R0 to R7. So every bank consists of 8 registers with the names R0 to R7. These are the registers for bank 0. Similarly, R0 to R7 registers for bank 1, R0 to R7 registers for bank 2 and R0 to R7 registers for bank 3. Each register can be addressed by name when its bank is selected or by its RAM address. For example, R0 of bank 3 can be addressed by the name as R0 if the bank 3 is currently selected, or by address 18H whether bank 3 is selected or not. The bits RS0 and RS1 in the program status word determine which bank of registers is currently in use. Register banks not selected can be used as general purpose RAM. Bank 0 is selected on reset. The second part of the RAM is the bit/byte addressable area. It is in the range from 20 to 2FH. A bit addressable area of 16 bytes occupies RAM byte addresses in this address range, forming a total of 128 addressable bits. An addressable bit may be specified by its bit address of 00H to 7FH, or 8 bits may form any byte address from 20H to 2FH. Thus, for example, bit address 4KH is also 4FH is also bit 7 of byte address 29H. Addressable bits are useful when program needs to remember only a binary event such as switch on, light off, etc. The third part of this RAM is nothing but the general purpose area. Above the bit addressable area, starting from 30H up to 7FH, is the general purpose RAM area, which is of size 80 bytes. Now we will study the pin diagram of IC 8051. The pin diagram is as shown in this figure. It is a 40 pin IC. Pin number 1 to 20 are to the left of this IC, and 21 to 40 are to the right. This is the top view of the IC. From the diagram, it is clear that many pins are used for more than one function. Here you can observe port 3, entire port 3 pins are used for some other function. Similarly, port 2, port 0 pins, they have alternate function also. The alternate functions are shown in parentheses. For example, this port 3 bit 0 pin is used for receiving serial data also. So the alternate function is provided in parentheses. We will see the pin diagram in detail, starting from pin 1. Pins 1 to 8. As shown here, pin 1 to 8 are nothing but the port 1 pins. Port 1, each of these pins can be configured as an input or an output. Pin number 9 is RST. RST stands for reset. Logic 1 on this pin disables the microcontroller and clears the contents of most registers. In other words, the positive voltage on this pin resets the microcontroller. By applying logic 0 to this pin, the program starts execution from the beginning. Pin number 10 to 17, as shown here, pin number 10 to 17 are nothing but the port 3 pins. Similar to port 1, each of these pins can serve as general input or output. Besides, all of them have alternative functions. Pin number 10 is RxD, serial synchronous communication input or serial asynchronous communication output can be provided on this pin. Pin number 11 is named as TXD. It is used in serial asynchronous communication as output or serial synchronous communication clock output. Pin number 12 is INT 0 bar, that is nothing but interrupt 0 input. Pin number 13 is INT 1 bar, that is nothing but interrupt 1 input. Pin number 14 is T0, counter 0 clock input. So external clock can be applied for counter 0 at pin number 14. Similarly, pin number 15 is T1. So external clock can be applied for counter 1 at this pin. Pin number 16 is write bar. Whenever write to the external RAM, that is additional RAM, is performed, this pin is activated. Pin number 17 is read, RD, that is nothing but read. So whenever the data is read from external RAM, this pin is activated. Pin number 18 and 19, as shown here, these are crystal 2 and crystal 1. Internal oscillator inputs are nothing but these pins. A quartz crystal which specifies operating frequency is usually connected to these pins. Instead of it, miniature ceramics resonators can also be used for frequency stability. Pin number 20 is ground. Similarly, pin number 40 is VCC. These are the supply connection pins for the IC 8051. So pin number 20 is to be connected to ground. Pin number 21 to 28, all these pins are nothing but the port 2 pins. That is, they can be used for as simple input output pins for port 2. If there is no intention to use external memory, then these port pins are configured as general inputs oblique outputs. In case external memory is used, the higher address byte, that is addresses in the range A8 to A15, will appear on this port. Even though memory with capacity of 64 KB is not used, rather whenever we are using external memory of size less than 64 kilobyte, then the remaining port bits are used for the input output operation and the required one are used for the addressing. Pin number 29 is PSEN bar, which is nothing but program strobe enable. If external ROM is used for storing program, then a logic 0 appears on it every time the microcontroller reads a byte from memory. Pin number 30 is ALE. ALE stands for address latch enable. Prior to reading from external memory, the microcontroller puts the lower address byte, that is A0 to A7, on P0 and activates the ALE output. After receiving this signal from the ALE pin, the external register, which is usually 74HCT373 or 74HCT375, which is nothing but the buffer, it memorizes the state of P0 and uses it as a memory chip address. Immediately after it, the ALE pin is returned to its previous logic state and P0 is now used as data bus. That is, the data D7 to D0 is sent on these pins. As seen, port data multiplexing is performed by means of only one additional integrated circuit. In other words, this port is used for both data and address transmission. Port 0 is used for transmission of data and address both, and the demultiplexing of it can be achieved with the help of the signal ALE, which is nothing but pin number 30. Pin number 31 is EA. that is external enable. By applying logic 0 to this pin, P2 and P3, that is port 2 and port 3, are used for data and address transmission with no regard to whether there is internal memory or not. It means that even there is a program written to microcontroller, it will not be executed. Instead, the program written to external ROM will be executed. By applying logic 1 to the EA pin, the microcontroller will use both memories, first internal and then external if it exists. As shown, pin number 32 to 39 are the port 0 pins. They are similar to port 2. If external memory is not used, these pins can be used as general inputs and or outputs. Otherwise, port 0 is configured as address output A0 to A7 when the ALE pin is driven high, or as data output D0 to D7 when the ALE pin is driven low.